Hello friends, myself Jyoti Samel. Today we will discuss disk scheduling operating system. Disk scheduling algorithm, which is also known as input-output scheduling. The purpose of disk scheduling algorithm is to reduce the total seek time. Here in this diagram, we are finding the various algorithm types. We will move ahead and we will learn each and every types in detail with the help of example. The first one is first come first serve, which is also known as FCFS. This algorithm entertains the request in the order they have arrived. It is the simplest disk algorithm. Advantages: it is simple, easy to understand and implement. It does not cause any starvation. Disadvantage: it does not try to optimize the seek time and may not provide the best possible service. We will learn this through with the help of the example. Suppose the order of the request is 82, 170, 43, 140, 24, 16, 190 and the current position of read-write head is at 50. Now we will calculate the seek time with the help of FCFS. As the head position is at the 50 and the first process is arrived at the 82, it will serve the first one, that is a 82. Afterwards, next is a 170. So my head will move ahead with to the 170. Afterwards, it's a 43. So my head will go reverse back to the 43. Like this, it will serve the next, that is 140. Next, that is a 24, 16 and a 190. Accordingly, we will calculate the seek time. From my head started moving from the 50 to 82. That's why we will subtract 82 minus 50 plus 170 minus 82 plus 170 minus 43 plus 140 minus 43 and so on. And the same way we are finding the answer for this example, that is a 642. This 642 is the seek time or the serving time for each and every disk movement. We will move ahead with the second type of the disk scheduling algorithm, SSTF, which is also known as shortest seek time first. This algorithm services that the request next which require least number of head movement from the current position. It is regardless of the directions, it will move left, right, whatever's the way. Only the criteria, that is the shortest seek time. Advantages: it reduces the total seek time as compared to the FCFS. It provides increased throughput. It is increasing the output time. Definitely definitely the speed is increased. It provides a less average response time and a waiting time. Disadvantage: there is an overhead of finding out the closest request. The requests which are far from the head might starve from the CPU. So it is creating the starvation. It provides a high variance, that is left to right, right to left, etc. in response time and waiting time. Switching the direction of the head frequently, it will slow down the algorithm. We will move ahead and we will learn the SSTF with the help of example. The same disk scheduling that is algorithm is over the same example that which we learned in the FCFS. The same example is over here. 82, 170, 43, 140, 24, 16, 190. And our current head position is at 50. Now my current head position is 50. It will find out that is the smallest one. Which one is the smallest among them? So definitely the 43 is the smallest. So my first position that it will move to the left hand side and it will reach to the 43. Now again it will calculate, it will find out from the 43 which one is the smallest one. Yeah, the shortest distance. After the 43, 24, 16 and so on. So like this way, we will calculate 50 minus 43 plus 43 minus 24 plus 24 minus 16 and so on. Here also we can take the simple solution 50 minus 16 plus 190 minus 16. Both the answers will be the 208. Hope you understood. In the FCFS algorithm, we have for the same scheduling algorithm, we got the seek time as a 642, and for this we got the answer that is a 208. This much is the difference. Now we will move for the third algorithm, that is a scan disk scheduling algorithm. As the name suggests, this algorithm scans all the cylinder of the disks back and forth. Head starts from the one end of the disk and move towards the other end, servicing all the requests in between. After reaching other end, head reverse its direction and move towards the starting end by serving all the requests which are arriving in between. The same process it repeats. Note, scan algorithm is also known as a elevator algorithm. This is because its working resembles the working of an elevator advantage. It is simple, easy to understand and implement. It does not lead to starvation. It provides low variations. Disadvantage. It causes long waiting time for the cylinder just visited by the head. It causes the head to move till the end of the disk even if there are no requests to be serviced. Example, same numbers we are seeing for the scan algorithm also. 82, 170, 43, 140, 24, 16 and 190. Our read-write head is at 50 and this is a very important line, that is the disk arm move towards the larger value. Here my 50, at 50 my head is that is a position, and the larger value means I want to move towards the 199 towards the right side. So here my disk head will move from 50 to 82, then 142, then 170 and so on. Okay, and like this way it will move towards the 199 and again it will come back from 199 to 16 by servicing in between all the disk head. Thus, the calculation part is very easy. 199 minus 50 plus 199 minus 16 is equal to 332. I hope you observe it very clearly. That is, here the 199 number is not there. Then too, as we have discussed in this, that is my cylinder will move to the other end. Start from one end and the disc will move to the other end. This is very important. That is a differentiate between the scan and the previous algorithm. We will move ahead with the C-scan. C-scan is known as a circular scan. Circular scan algorithm is an improved version of the scan algorithm. Head starts from the one end of the disk and move towards the other end, servicing all the requests in between. After reaching to the other end, head reverses direction, but it will not serve in between requests. Advantage. The waiting time for the cylinder just visited by the head is reduced as compared to the scan algorithm. It provides uniform waiting time. It provides better response time. Disadvantage: it causes more seek movement as compared to the scan algorithm because while reversing, it is not servicing. It causes the head to move till the end of the disc even if there are no requests to be serviced. Example. Same example we are seeing once again. My disc arm is at the 50 and we are moving towards a larger value. Here 50, 82, 100, everything that is a we are servicing, but our the disc arm here that is our it will move towards that is 50, 82 like this way till the 199 and now it will reverse back. But while reversing, it will not service. My cursor my disc head will come to the 0 and again it will start the process. So here we are finding 199 minus 50, 199 minus 0 and 43 minus 0. So the answer will be 391. Next algorithm is a look-disc scheduling algorithm. Look algorithm is an improved version of the scan algorithm. Head starts from the first request at one end of the disc and move towards the last request at the other end, servicing all the requests in between. After reaching the last request at the other end, head reverses direction. It then returns to the first request at the starting end. See, here in my C scan, my head reversed and it arrived at the 0 position. But in look, it will not go to the 0 position. It will come to the first, that is a first head. It then return to the first request at the starting end, servicing all the requests in between. The same process is repeated. Here is a difference between scan and a loop. Scan algorithm scan all the cylinder of the disc starting from one end to the other end, even if there are no requests at the end. Look algorithm scan all the cylinder of the disc starting from the first request at the one end to the last request at the other end. Advantages: it does not cause the head to move till the end of the disc where there are no requests to be serviced. It provides better performance as compared to the scan algorithm. It does not lead to starvation. It provides low variance in response time and waiting time. Disadvantage: there is an overhead of finding the end request. It causes long waiting time for the cylinder just visited by the head. Here we will see the same example but with the help of look algorithm. Our head position is at 50 and it is moving towards a larger value. Head is initialized at 50. It is moving till the 190. Now again it is coming back and then it will move till the 116. Here you can find out that it is moving in one direction and 190 minus 50 plus 190 minus 16 is equal to 312. See look, disc scheduling algorithm, which is also known as circular look algorithm, which is an improved version of look algorithm. Head start from the first request at one end of the disc and move towards the last request at the other end, servicing all the requests in between. After reaching the last request at the other end, head reverse its directions. It then returns to the first request at the starting end without servicing any request. Advantage: it does not cause the head to move till the end of the disk when there are no requests to be serviced. It reduces the waiting time for the cylinder just visited by the head. It provides better performance as compared to the look algorithm. It does not lead to starvation. It provides low variance in response time and waiting time. Disadvantage: there is an overhead of finding the end process. We will see the example. Again, same numbers: 82, 170, 43, 140, 24, 16, 190, and the read-write arm is at 50 position, which is moving towards the larger number. From the 50, it will move towards the right hand side, that is a larger number, 82, 142, and so on till 190. It will reverse without servicing, and now again it will start the servicing once it is reaching to the beginning or the first request. So here the calculation: 190 minus 50 plus 190 minus 16 plus 43 minus 16, the answer will be 341. Hope all of you understood this. Here now we will see all the 6 disk scheduling algorithm in a Hello, we will see in short FCFS, SSTF, scan, C-scan, loop, and C-loop. Here, FCFS is serving each and every request as per the arrival time. SSTF, shortest seek time, it will serve as per the shortest time in between the two requests or the ticks. Scan is, that is, it is moving towards either the one end, and it is mentioned over here towards the larger value. It will move from the 50 to the largest value till the end, and then again it will reverse back by servicing all the in between request. C-scan, circular scan, it will move towards the larger, but again it will reverse it back, but while reversing it will not service any one of the requests, and again it will repeat the same process. Loop, in the loop it will move from the 50 to the 190, and then from 190 to the 16. And C lookup, that is circular lookup, it will move from the 50 to the 190. Again it will reverse back, but it will reverse till the 16, and then again that it will repeat the process. So here we can find out the costliest that is the algorithm in the disk scheduling is the FCFS, which require 642 as a seek time, and the shortest one or the minimum, that is a seek time, it's consumed by the SSTF, that is shortest seek time first. Thank you. I hope all of you understood, and please click on the subscription button. Thank you.